Okay, welcome everybody to this afternoon session as part of Maths Week Scotland. We are from the Open University and we are doing a session on code breaking today, a little bit of an introduction to basic cryptography. My name is Charlotte Webb and I'm a lecturer in mathematics education.
And my name's Andrew Potter and I am a staff tutor at the Open University in Scotland as well, so I'm based in Edinburgh.
And both of us do a lot of external engagement, so we really enjoy working with people outside of the university and working with schools and adults and children from different walks of life. So it's really nice to see you all here today, and we're really excited to run this session with you. I'm going to pop up the next slide, which is going to have a bit of a kind of introduction practice session for you. So there's two things for you to have a go at from this first page. So first of all is trying to crack the code, which is in the blue box, okay, and there's something on the screen that might help you. You might also recognize this particular type of message, but the other thing that we'd like you to do is to practice using Menti. So I'm going to pop it into the box, menti.com. If you go to menti.com and you actually type in the number that is on the screen, I'll also paste it into the chat box for you so you can copy and paste it. Then shortly, I'm going to give everyone just a chance to get that up. Shortly, I'm actually going to set that as a challenge. And what you are asked to do, is once you've cracked this code and worked out what the secret message is in the blue box, you're going to type it into menti.com. So it's just a little warm up, but we're going to use this as a practice because we're going to be using Menti for the rest of the challenges. It's just basically a way to work against the clock. So we'll talk a little bit more about that in a moment, but I'm going to start the Menti presentation now. So as soon as you're ready, you should get, so I've got 3 people already jumped on there. I've got somebody who's got a little icon of feet, somebody who's some little hearts, and a little bunny. So I'm just going to give a few more moments for more people to join menti.com. Got a ghost and a tiger. And I will start the countdown shortly. Got paper clip.
Yeah, am I right in saying as well, Charlotte, though, that if it's already started, you can still join the Menti session at any time?
Yeah. Once it's started, you can still join. It just means the countdown's already started, and you might not be the first person. It's going to be a bit of a competition to see who can crack it first. So I'm going to start it now. If you've already got your answer, it'll be quick. You can just type it in away. So you should get something coming up now to say that you can enter your challenge.
And welcome to anybody who's just joined us a little bit late. I noticed that we've got a couple of extra attendees have joined. If you are coming in a little bit late, then the first thing you want to do is to go to menti.com, and that's probably best to do on whatever device you want. You can do it on your phone, or you can do it in an extra tab on your browser, or whatever you like. Put in the code there and then try and decode this message that's just appeared that Charlotte's put on the screen there.
Time is about to run out if you have just joined us, but that was just a warm-up, so do not worry. Okay, we've got 5 answers within the time. So that was just a practice run, as I said, to get used to logging on to menti.com. If you are still cracking the code because you've just joined us, feel free to add it into the chat box now. I think everybody's had a little bit of time to go, so you can send it to everybody if you like, or just to us.
Yeah, any ideas then? Anybody who wants to type it into the chat box and let us know what is this? How do you decode this message? What does this message say? Yes, as I see, Kathy has got it. She's sent it privately just to me and Charlotte. Natalie's got it as well. Well done. Yeah.
So the fastest person for that round was Christabel. That was just a little warm up, so not a problem. But Christabel was the speediest that time. Open University, indeed. So the message is not such a secret message, but just the name of our university. But does anybody know what kind of message this is? What kind of cipher this is? Has anybody got an idea of where this comes from? What it's about? So a couple of people have said Morse code. Anybody say anything else? What is Morse code? What's it all about? What are these symbols? representing. Some of you might have been watching some TV programs recently. I've been watching one about some people in a submarine, and this comes up. Particularly somebody, I'm not going to do any spoilers because somebody might still be watching this particular show, but it gets used in the show. So has anybody got any idea what kind of, how this is used, what these symbols sort of mean, or an example where it might be used? So on ships, someone says, okay, what kind of, how do people use it on ships? What's military communication? Indeed, yes. And telegrams, yes. Okay, so telegrams is quite a big clue. How is it used in telegrams? And it was used during many different wars, and I think it is still used by lots of people. So what do telegraphs use, and kind of why is the Morse code particularly useful for that? See if anyone can give us anything more before we say anything further. Yeah, writing in codes can protect information. It can be used for binary on and off. Yeah, it's also, the telegraph thing is quite a big clue in terms of it's quite often used for sounds. So the dash and the dot being a longer or shorter sound. Can also be used, a lot of people said ships, which again, it can be used on communications and ships, but also through lights. SOS, yes, exactly. That's a very, very popular use of it. SOS being we can have a look. You've got, see, the reason why it's chosen, because you've got 3 dots, which is quite easy, and 3 dashes. So it's kind of the simplest 2 letters in a sense in the Morse code. So you do 3 shorts, 3 long, and 3 shorts, and it's used in this show that I watch, banging on walls. So that's just a basic type of code, and the simple one that lots of people know, particularly people in the military. We're going to introduce you to a couple more codes today, and quite a few actually, and talk to you a little bit about the way that things are encoded and decrypted. But first we'll kind of go back to think about code breaking and some historic people and figures. If we can move on the slide, please, Andrew. Does anybody know who this is? Great to get some people in the chat box. Alan Turing. Okay, who's Alan Turing? So in my office in Milton Keynes at the Open University, I am in the Alan Turing building. So we have chosen to name our building after him. Oh, Enigma machine, I saw. Code breaker, help solve Enigma. Cryptanalyst, yep. GCHQ. Okay, and what about this picture on the screen? So this is not the Enigma machine, because some people have mentioned Enigma machine, but this is something to do with it. What is this on the screen next to Alan Turing? Does anybody know? You sort of all talked about it. Bletchley Park's been mentioned. The bomb, yeah.
Yeah, that's right. And Chris is saying that this is the machine that cracked the Enigma code. Yeah, well done. Yeah, definitely.
Yeah, so Alan Turing is a big hero of mathematics and cryptanalysts. Basically thought of sort of the grandfather of computer programming as well. It all sort of originates from the work, not just Alan Turing and the code breakers at Bletchley Park. He's sort of well known from there. If Andrew wants to add anything.
Yeah, I mean, I think Alan Turing is one of these real interesting characters, of course, because some of the parts of Alan Turing's life that are really the saddest part was that, you know, he was very much persecuted by the UK government for being a gay man, and that's really something that we. You know, it seems really a strange juxtaposition of things that, you know, that he's this war hero who then was kind of really badly treated by the UK government. So I think it's really important that we remember him and all the rights and equalities that we now have, we take for granted. So yeah, no, a very interesting person and lots of interesting historical information about Alan Turing.
Definitely, yeah.
All right. Okay. I think that. Does anybody know where this is? Does anybody know where this building is? What is this building?
So we've got Bletchley Park. Yeah.
That's right. Yeah. That's right. That's Bletchley Park there as well, where, of course, during the Second World War, Alan Turing plus other code breakers worked very hard to break things like the German Enigma code, and we're going to be using quite a few of the techniques that they developed maybe later on. But we're also going to be looking back a little bit further in history as well.
Yeah.
All right.
I think the next picture is if you keep clicking onto, there's
Ooh.
actually, if you want to go to Bletchley Park, it's not far from the Open University, so it's close to Milton Keynes. But you can see a rebuild of the bomb. So there's a sort of accurate rebuild, and they have experts there who can talk to you all about how it works and actually show you how it works. So it's definitely worth a visit if you ever find yourself in England and in the south, and you have some spare time. Definitely worth a visit. Yeah.
It is brilliant. I highly recommend it. Yes. There is where it is, in case you were wondering.
Yeah, the reason this is on here is because there's questions about why is it there, and you might have some suggestions. But it's in Milton Keynes. If you don't know, is a pretty new town. The Open University just had its 50th anniversary recently, but most of Milton Keynes wasn't actually around when Alan Turing was at Bletchley Park. So, why was that chosen? Well, you might have an idea, but one of the reasons is because they wanted to keep it away from big cities. So London was obviously going to be a dangerous place to have something as important as your wartime code breaking team. And you need it to be away from anywhere that's going to be likely to be bombed, but they also wanted to have good connections. And you'll see that there was a road there, which is now the M1, but it was a more basic road at the time. And there also were train connections from Oxford, Cambridge, and London. Exactly. So you had a lot of your code breakers were sort of recruited from these kinds of places, Oxford students, and being able to get communications to and from London on these mopeds and things was really important. So that's just a very, very, very brief history of Bletchley Park, but you will find out a lot more if you go there. So I do encourage that. And if you can't, they have virtual sites that you can have a look at on their website.
Definitely. All right, so we're now moving kind of away from the Second World War. I'm going back to one of the very, very first recorded ciphers. So by a cipher, I'm talking about a way of encoding a secret message. Does anybody have any idea, when this cipher might have been used? What sort of time period do you think that this might have been used in? Put your answers in the chat box if you think that if you've seen this before. This is called a Cytale cipher. Anybody, any idea? Someone guessing 1932, a little bit earlier than that. When this was first used, I should probably say, might well have been used in 1932 as well. Suggestion of Tudor times, 1917. I should say that this is a replica. The picture that you see on there is actually a replica of the original cipher. It's not the thing itself. But when would something like this have been used? Yes, ancient Greek, Roman times, yeah, absolutely. Yeah, this was first recorded around about 2,500 years ago. This particular type of cipher. And it just works by the message itself is just written on this leather strap that goes all the way around. And the way that you decoded it was to just wrap it around the end of a sword, the handle end of a sword, and that would line up the letters in such a way that you'd be able to read the secret hidden message. So there was a very, very simple and very effective, actually, way of sending secret messages about military matters in those ancient times, in ancient Greek, ancient Roman times. So yeah, very ancient ideas, but very easily broken nowadays. But you have to remember, of course, that 2,500 years ago, not everybody could read, so it wasn't necessarily that difficult to send secret messages. All right, but we're going to start with our competition proper now. So what I need you to do now is to go onto Menti and again, so menti.com is where you need to go and enter in the following code here. So it's a different code from the one that you started with. So menti.com, and the code there is 84 39 99 34. If for whatever, it's best if you can log on to this. It's the easiest and funnest way to kind of participate in this. If for some reason that you can't, if for some reason that you can't use this or can't get it to work, don't worry, you can always do this without using Menti, but it makes it more fun. And also there's a bit of a competition about who can crack all the codes the fastest. So Charlotte, are we, I'm not sure how many folk have we got signed up on Menti?
I'm just having a quick look. Oh, quite a lot. Oh, 40. Excellent. 41. Okay, so lots of people are ready to go. How many people have we got on in the participants list roughly?
We've got 31, so that we've done well to get 40 people signing up to Menti. I think there might be some people here who are perhaps a classroom of people.
Group. Yes, because we've got more than that already. Okay, I'm going to give everybody just a minute or two because there's a few people popping up now. Yeah, we've got sort of over 50 now, so brilliant. I'm going to start the countdown shortly.
All right, so this is the code that we're wanting you to solve. But first of all, in order to be able to do this, you're going to need to have a key. So I'm not going to tell you how to use the key yet, but I am going to give you the key here. All right, so Charlotte, if you open up the Menti now.
Starting it now.
The race is on.
Okay. The race is on.
So here we go. This is the code that you want to go to.
It should be ready now. It just takes a few seconds to come through. Go on. Yeah, you've now got just 3.5 minutes to try and crack this code. So you can be the fastest person and get the most points, but you've also got 3.5 minutes. So use the time if you need it. You've got there a key, and you've got to try and work out how that key relates to the message. Your pen and paper will come in handy, I imagine, because it's hard to keep it all in your head. You see, absolutely, yeah. Victoria's got her hand up. I don't know if that is a new hand up or been there for a while. Would you want to chat in the chat box, Victoria, and tell us if you're having an issue or anything with the link?
Oh, we're getting there. I think some people are getting there with them. I've got Kathy's given us an answer, but it's not quite the full answer yet. Ooh, have we got anybody who's managed to submit an answer yet, Charlotte?
We have got 6 answers so far, so 8 now. Yeah, they're coming in.
Oh, excellent. We'll see if those people who were the fastest were also the most accurate as well.
Yes, indeed. There's 2 skills here, isn't there? Speed and accuracy. So we don't normally worry in maths. We don't normally try and push you for time. It's all about taking your time and getting there in your own way. But we added this element of speed to this challenge purely to give you a little bit of a sense of urgency, because the code breakers at Bletchley Park and elsewhere in military situations always have to try and crack the messages as soon as possible to try and put them into place to try and stop the attacks happening, or to try and position their ships appropriately to sort of sort out their maneuvers in wartime. So it was always very urgent, and time was really important. So that's why I've added this element. But do take your time. If you need a bit longer, the codes are on the screen, and you can always take a screenshot as well with your phone and have a go at them later. So don't worry if you feel like the time is putting you off. Do take your time. But actually, loads of you have done it, so not too much of a problem. 37 of you have already answered, so nice and speedy there. Obviously, crypto experts. Has anybody seen this type of cipher before? Perhaps if you have, you can type in the chat box and tell us. No, it's new for some of you. We're going to tell you all about it shortly, but give everybody a little bit more time.
All right. I wonder if anybody's still struggling to work out what these things are. Maybe I'll give a wee clue, shall I? So, for example, this first symbol here that you see that I'm drawing here, where do you see that again? You might see it on this grid as the same shape there. Yeah, so I think that shape there might represent the letter D. All right, so if you're, hopefully that helps anybody who's struggling to get it. That seems like that this first letter might be a letter D.
Yeah, perfect. I've just had a look. Time is up, and we've got 47 answers. 23 of you got it perfectly right. I think I'm going to have a quick look because I think some of them might be just little typos. So we've got a missing S, for example. I'm going to let that go, I think.
Excellent. Right. Well, okay. Shall I, while you're doing the marking, as it were, shall I have a look and see? Well done to those of you who got this. Oh, how do I clear this? Let me just get rid of those annotations. First of all, there we go. So well done to those of you who got the answer to this. The answer was, of course, by the end of the session, you will be able to decode messages using different ciphers. So well done if you got that. And did we have somebody who who was fastest?
Yeah, let me just have a look. I'm just giving everybody, not everybody, but I'm giving most people ticks who had a very minor typo. Okay, so let's. Oh, okay. I think we're going to do a leaderboard after 2 rounds.
All right, good idea.
No, after the first few rounds. So we will leave that for now. But yeah, really good. So we had nearly everybody got that right, I think. So good job. If you didn't get it quite right, it's probably just being a bit careful with the way you type things in.
Excellent. Good to hear. So anybody, so a little bit of historical information about this particular cipher. This is called a pigpen cipher. And the name comes from presumably because the way in which you use the grid is kind of like penning in pigs into different shapes of fence. So that's kind of where it gets its name from. But it was extensively used by a group of people that are associated with this particular symbol. Does anybody know which group of people, which secret society of people that this might have referred to, this picture that I've got here? Yes, a couple of people have said it. Yeah, that's right. It's Masons or the Freemasons, absolutely. So the Freemasons were a secret society who used this cipher to keep their messages secret. So if you have a look on this particular, this is somebody's gravestone who was a Freemason, and if you zoom in on this bit here, as I've done, you'll see that it says Thomas Brierly, and then you'll see these kind of pigpen cipher there. And what that actually says, if you decrypt it, is Thomas Brierly made his ingress on July 16th, 1785, which is thought to mean that that's when he joined the Freemasons. So they used this extensively. So the pigpen cipher is, as you see, it uses this as its key here, but it's an example of a diagrammatic substitution cipher. Every single letter is substituted by a particular part of a diagram, but it's not the only one that you could use. So the key that we used was this one here, but you can use a different type if you like. So this is another way of arranging the letters of the alphabet into these sorts of pigpens here. So it's slightly different in that you go from I and then K goes here, whereas before we had from S. Or you could rearrange them in like this, or like this, or like this. There's various different ways and variations on this kind of idea. You could even have the positions of the dots will tell you what the letter are inside these things. So these are all a class of ways of encrypting that are called diagrammatic substitution ciphers. here's another one, which is using a square that's divided up into quarters, and the position of where a dot would be would tell you what letter it is, and your symbols become parts of triangles and dots there. So really, the challenge here is, why don't you make up your own? And if you have your own secret key, you can send your own secret messages. All right, but what we're going to do just now is we're going to move on a little bit onto our next round and look at a completely different cipher. So this one's called a Polybius Square. And it's called a Polybius Square for many reasons, but one of the main reasons is that there is a keyword that's called Polybius, which we write into the first 8 letters here into the square. You'll notice that I've got I/J, and we'll talk about why that is in a minute. But the key thing here to think of is that we fill out this. We always start with a 5 by 5 grid, and we have a keyword. In this case, it's Polybius, and then how we fill out the rest of the square is just the rest of the letters of the alphabet in order that haven't been used yet. So that's why I've got then A. I've already used B, so I use C, D, etc., etc., etc.
One of the reasons why Polybius is a good keyword is you don't have lots of repetition. If your keyword was banana, you'd end up having to, well, it would just be BAN because you'd have already used the A and the N. So it's good to have a keyword that's got lots of different letters in it.
Yeah. Does anybody have any idea of why have I got I/J? There's 2 reasons that I can think of, at least, why there's I/J. Why are I and J both in the same square? Anybody got any idea why that would be? I can think of a mathematical reason, and I can think of a historical reason. Yes, that's right. That's right, Nigel. Yeah, that's one good one, and Dave as well. Yes, exactly. Yeah, and yes, absolutely. So Louise has got it as well. There are 26 letters in the alphabet, but there's only 25 squares. So we have to have at least 2 filling the same square. And as Christabel points out, it's obvious what's meant. If it's an I or a J, you're not likely to get those 2 things mixed up. Another reason why this is a historical reason why I and J are both the same is that, well, historically, at least, like Latin, on which our alphabet is written, didn't distinguish between I and J originally anyway. They didn't have separate letters I and J, so they used the same letter for both. So that's another reason why. So anyway, given that here is a message that's encoded now using this Polybius square. So let me just kind of show you how it's to be decrypted. So if I can get my annotation up.
Oh, you get that. I wonder if anyone can sort of guess, like if thinking mathematically, if you wanted to describe how to get that F, for example, how would people maybe do that? Type into the chat if you have an idea, or just the kind of maths that you think this looks like. What does it make you think of?
Oh, yes, pairs of coordinates has been suggested. 3, 3. Someone's saying 9. I'm not sure what that means. Or 3.
Well, I guess 3 times 3 is 9, so that could be F. That makes sense. Or 33 being just the 3 and the 3 without a comma.
F equals 3, 3. Ah, yeah, okay. So that's a very interesting one from Serena. So 3, 3 would be like coordinates of 3, 3 gives me this letter F here. Okay, so in that case, maybe these are to be split as pairs of coordinates. So if we were to split these into 2s, they're like coordinates, 2, 3, for example. So what would that first letter be then? What's 2, 3? 2, 3 S. That would be 3, 2, because we remember in coordinates we always go along first and then vertical. So we always go horizontal then vertical. So it's E, that's right, yeah. So this is actually E. It's 2 along, then 3 down. Oh, oops, I've only gone 2 down, 3 down. So it's...
There's a good point about the order, because we're assuming the mathematical way that we do it, that it could be done differently in a different key?
Yes, absolutely. Yeah. We in maths we always do horizontal, then vertical. But yeah, there's no reason why you couldn't create a different code that used vertical then horizontal. And as I think many other people have pointed out now, the whole message now reads, if we go to then 4, 5, you'll get X, and then if you do 4, 2, you'll get A, M, P, L, E. So the whole message reads example. Okay, right now, do you think you're ready to try this on your own then? We're ready to have this as a message? Would it hint too much if the heading row would be at the bottom instead? Aha, yeah, perhaps so. You can think of your headings to be like 1, 2, 3, 4, 5 as well, perhaps.
Yeah, and I think you could get rid of them altogether if you knew the system.
Yeah.
And just had the 5 by 5 grid, and that would make it a bit more mysterious for the person trying to crack your code. I think that it would quite often just be a 5 by 5 grid with no numbers. Absolutely,
yeah. Great. Okay, I'm going to clear all my annotations so we can move on to the next slide, and we're ready for the next Menti challenge. It's just, those of you who are still logged in, you should be able to still participate without having to log in again. And round number 2, here we go. Here is your challenge.
Yeah, if you have, I've lost a couple of people, so if you need to log in again, there's the code. But there's still quite a few of you here, so we'll start it now. Okay, it's just loading up.
Here we go. There's the code if you need to go on Menji.com. And then the code is that. So yes. So remember what we did the first time. I think the easiest thing to do, I don't know what you think, Charlotte, but I think the easiest thing to do here is to separate out the coordinates, the pairs. So maybe I'll do that. So separating the pairs.
Yeah, this is where your pen and paper comes handy, because you can jot these down.
Yeah, it's very easy to get muddled if you don't separate them.
Might even be worth copying the grid down if you find it easier to circle things. And some people are more inclined to draw rather than just see things on a screen. So that's what I might do. A couple of people messaging us what they've got so far. We'll see whether get the whole thing. I haven't got anyone who's finished the whole thing yet, but it is a bit of a longer message, so give you a chance.
Oh yes, this one takes a wee bit of a while.
Yeah.
Yeah, I wonder. And people who are thinking.
2 people have done it actually.
Fantastic. Kathy's getting there as well.
Yeah, if anybody doesn't get on with Menti or can't get it open in another window, I know it can be fiddly, just message hosts and panelists only, and you can send it just directly to us.
I wonder if anyone's spotted any particularly easy ways of doing this. Any particular strategies that have worked really well?
They always say that mathematicians, and I think it applies to code breakers as well, are lazy and they like to find quick ways or tricks or sort of things that help you, not having to do all the work.
Yeah, exactly. Yeah, some of the things I was thinking about is I see that there's I see that the pair 1, 2 appears quite a lot actually. Yeah, so actually when I see that the pair 1, 2 appears a lot, then I could just, all I need to do is decode it once and then like put that in every time that I see it, that's quite a useful thing.
Definitely, and it's going to be something that's useful when we get to the even more hard ciphers.
Yeah.
More challenging ciphers is you need all these tricks and quick things. You don't want to be decoding the same letter multiple times.
Exactly, yeah.
Okay, let's have a look. Oh, lots of people have done it now. We've got
Excellent.
just over a minute left. I think 2/3 of people have done it now.
Just for anyone who's struggling, like that, what I'm thinking is, for example, what did I say? 2, 3, for example, is an E, and it appears quite a lot. There's 2, 3, and there's 2, 3 there as well. So I can do them all in a oneer. Oh, there's 2 E's there. And then there's another one here. So that's quite useful to be able to do them all at once in some sense.
And then eventually, if you get loads of letters, you can even sometimes guess what the rest of the word is.
Yeah,
exactly. If you've got most of it. And like somebody said earlier about the I and the J thing, you know, some make sense. It's the same with kind of looking for clues and using your, I mean, you know, as long as you know the language that it's in, and we're using English today, then that gives you maybe some clues.
I see Nigel's saying a shortcut, a cryptic Eratosthenes sieve. Yeah. Absolutely. Yeah.
Let's have another look. Oh, okay, time is up, and 42 people managed to get an answer in.
Excellent. Good.
I'm just going to give a few typos again. Oh, some people have done that guessing thing and they've guessed slightly not the right words. But you know, good for you. Someone's put the Cipher is an ancient Greek masterpiece, so they just kind of guessed the last word. You could argue that it is, but that wasn't the right answer. And some people have said message rather than cipher and things like that, but I think lots of you have.
Good, I'm glad. Right, okay, well, so the answer to this one then is going to be, what you should have got here was this cipher is an ancient Greek invention, which is true, of course, and Polybius, I should have mentioned, is actually a named person. It is actually this person on the right hand side here. The Polybius was a historian mainly. He was a Greek, but he lived in ancient Roman times when Rome kind of ruled the Greece as well. So yes, he has this kind of Latin sounding name, but he's actually a Greek person. But yes, and he's attributed to this as well. That he supposedly used this. But as Charlotte pointed out before, his name just so happens to only have one, or what am I trying to say? His name happens to be one of these names that only has each letter once. So that works well. So my name, Andrew, would work well, but Potter wouldn't, as a particular one, because it's got 2 T's in it.
And Charlotte has 2 T's as well, so
yeah. Exactly.
I'd lose one of them, although people always spell that wrong anyway. So
yeah.
But somebody obviously has maybe heard of this person because they guessed the last word was philosopher, which is maybe because they know who this person is. So yes, interesting.
Good guess. All right. Okay then. So we're I think are we moving straight on to round 3 then? Are we, Charlotte?
Yes. We'll do a leaderboard at the end of the 4 rounds. We'll just keep cracking on for now, cracking codes. All
right. Okay, over to you, Charlotte.
Okay, so we're kind of coming forwards now in history. So we've gone very far. We talked a little bit about Bletchley Park at the beginning. Everything we do today in terms of code breaking, if anyone has any idea about cryptanalysis, is kind of fairly ancient in terms of nobody does this anymore. In terms of the way that people use codes is much more complicated and sophisticated now. However, the closest we're going to get to modern day cryptography today is by looking at binary. So first of all, has anybody kind of heard of binary? If you have, type in the chat box, what is it? What does it mean? You might have heard it in different contexts. You might have used it for something, depending on your background. I know a few of you, someone said 0s and 1s. A few of you said at the beginning that you're doing computing or mathematics, so you might have seen it. So computer code, okay, so Dan's using it in computers. Dave said on or off, that got mentioned earlier as well, as switches. So you might be in electrical engineering, lots of people use it in those kinds of things, computing, mathematics, codes, base 2 arithmetic. The chat's jumped up now, but I think somebody else said about things to do with base 2, and people are doing it in arithmetic, base 2 arithmetic. Okay, lots of people have heard of it, and logic. So you might already know this, but there might be some people for whom this is new. So we're going to have a look together and do a little bit of a run through of kind of what this means. So Andrew's going to pop up 5 sort of questions, and if you know what these numbers mean in what they sort of translate to, can you write it in the chat box? So we've got here a binary number, which is 00010. Now, somebody said base 10, the base 2 in the chat box, and we actually work, as Andrew's mentioned earlier, in base 10. In our number system, we work in base 10, so we work in units, tens, hundreds, thousands. So whenever you write a number, generally, unless you're working in base 2 or something else, generally when you write a number, you're talking about base 10. If I write down the number 317, I'm talking about 317. It's 3 hundreds, 1 10, and 7 units. Yeah. So that is our number in decimal in base 10. So in base 2, it's very, very similar. So we don't have units up to 9 in base 2. In base 2, we only have 2 different possible options. We have 0 and 1. Okay, but I've seen a lot of people have written 2 here. So, and we've got a few other answers coming in from Kathy and other people. So let's explore why this first number is actually 2. So if we click on the next slide, I think it gives us a little bit of a hint.
Let me just, oops, sorry, because I'm annotating, I'm not getting a chance.
I might be able to move the slide. Okay, there we go. There we go. Okay, so that gives us a little bit of a clue. So it's a little bit like hundreds, tens, and units. But we're going to be working in base 2. So instead of looking at units and then tens and then 100 is 10 squared, 1000 is 10 cubed, and so on. Instead of looking at powers of 10, we're going to be looking at powers of 2. So what's the first column on the right? Why is it 2 to the power of 0, and what does that mean? Does anybody know what 2 to the power of 0 is and how that relates to our sort of hundreds, tens, and units? It's not 0 actually, although that is a good idea. 1, yeah, so 2 to the power of 0, anything to the power of 0 is actually 1. And so that's our unit column. So that's our ones. Okay, in every base that we look at, we need some units because we need some, well, what if there isn't a whole 2? What if there's a bit left over? So that's our units, okay? And then in the next column, we've got our 2s. So 2 to the power of 1, that's just our 2s. And then in the next column, which would be your hundreds, which is 10 squared, we've actually got 2 squared instead. So we've got 4. So as we go up in the next column in our sort of binary system, we're going from 1 to 2 to 4. What would the next one be? It's just like place value, exactly. 8, yeah. So we're going in powers of 2 instead of powers of 10. And that's basically the difference. And the last one is going to be 16, 2 to the power of 4. You can keep going indefinitely, and it will just carry on doubling, going in powers of 2. But we're going to stick with 5 digits here. And as I mentioned, it's a bit easier in a way than the decimal system, because in the decimal system we have 0 and then we have 1 to 9, whereas here we just have 0 and 1. So once we get to 2, we go back to 0 again. It's a bit like tens. Once we get past 9, we go to a 1 and a 0. So it's just very similar to that. So as lots of people said in the chat, this number here is just the number 2. And the reason for that is because these numbers here, 0, 0, 0, 1, 0, they match up with these columns. Okay, so instead of that being a 10, it looks like a 10 with just some unnecessary zeros over there, but it's actually 2 because it's the second column that we're interested in. So if we have a look at the other examples, you can hopefully use this grid to work out what they are. So if you click a couple of times, Andrew, it should pop up the other 2 as well. Harder to annotate, isn't it?
Yeah.
There. So can you have a go in the chat box at finding the other 3 examples? And we'll just check that everybody's happy with finding binary, because this is going to be a big part of the next challenge, is going to be converting these binary numbers into base 10 numbers. We've got 31. Okay, I think that looks good. 31 for the second one. Now, again, I talked to you earlier about tricks. Does anybody know a trick for finding that one? Without having to, because that looks like the hardest one, because you've got to add up a 1, a 2, a 4, a 8, and a 16. Did anybody find a quicker way of getting that one? Second one, I think the unanimous on 19, and the last one on 5. So we'll just pop those up. And meanwhile, can anybody see the trick that I sort of use for the second one? I'll give you a clue. What would the next, if I had the next number up? It would be 1 0 0 0 0 0 0 0 0 0 5 zeros. Yes, so Nigel said exactly. So it's like the next column would be 32 because it would be 2 to the 5. And that's everything you can get up to before you need the next column. So it's the last number before you need the next column. So it's 31. So whenever you have, especially if you have a list of if you had a list of 9 ones, you just need to know what 2 to the 10 is. And then, well, 2 to the 9 because you start with 0. And then take 1 away. So that's a nice trick for you. Okay, is everybody happy with binary, 5-digit binary numbers? We're going to, when we do the next challenge, we're going to leave a little sort of hint box up there to help you with an example on it. And if you are stuck, just message us privately on host and panelist chat and we can help you. But I think we'll be ready to start now if Andrew wants to start the next page.
Yep, let's get on to that. Oh, let me just clear the annotations first of all so it's not a mess.
Thank you.
There we go.
Okay, so I'm going to start it momentarily, but I just want to make sure everybody's happy with what we're doing first before I start the timer. So you'll see here that you have some numbers in binary, okay? Now your first challenge is to convert those numbers into numbers in base 10, okay? So you need to do what we just did, basically turn them into the numbers that we recognize, okay? And once you've done that, you'll see at the bottom, it's very straightforward. 1 is A, Z is 26, it's all in order. There's a code to change it to a letter. So once you've got the number from binary into base 10, then you need to convert it to a letter, and that will be your message, okay? So there's a little clue up there, an example to help you, which is just on the bottom corner on the right hand side, and all the keys are on there. But if you are stuck, then do send us a message. And I'm going to start the countdown now, so you've got time to work through it. Giving you quite a bit of time for this one.
Yeah, it takes a wee while.
Got just about 5 minutes, so it's a little bit of time. So do take your time to just make sure you're happy with what you're doing. And it gives everybody time to message us if you are stuck and you want help with it.
Great, yes. Yeah, so that just to get people started there's an example that this first letter here over here on the left hand side, 0 1 1 1 1 1, and then as it says here on the bottom right here, we've got that's there. We add up the 1, the 2, the 4, the 8, and you get 15, which you then can see that is an O. So this is the letter O.
Exactly, yeah. So it's a little bit of a time process, but hopefully you've got your handy piece of paper and you're able to convert these.
Absolutely. And remember, Charlotte, those quick ways of doing things as well, so that we're not necessarily the best way is just going from left to right as one in order. Yeah, I wonder if anybody has any ideas of how to do this a little bit more smartly and a little bit quicker. Good to see. Emiko, no, that's
not. It's a good guess, but it's not the right answer.
It is a good.
That is one strategy, though. You inadvertently given us a strategy, which is guess, which yes is a good one to do. But you sometimes need a bit more information than just the first letter. It is a good guess.
Yeah, one of the good. Yeah, I think that's one a really important thing is that cryptographers and cryptanalysts, they do guess. That is part of the thing, but you have to be able to check your guess. Mm-hmm. And the guess that you gave there, Emiko, you can tell that it's not right by just decoding the second letter, and you'll see that the second letter doesn't match up with with your guess. So that's not going to work.
We've got another hint in the chat. Can you see that, Andrew?
Yes, that's great. Yeah, thanks, Bob. Yeah, going right to left and only using 1, 2, 4, 8, and 16 as needed. Just ignore the zeros. Yeah, and then add up those numbers and then decode as the correct letter. Good. Thanks for that, Bob. Yeah, this one's also one of the ones that makes this one quite tough is that you don't know where the separation between words is necessarily, which is a real help in cryptanalysis. When we had ones before where you knew where the separations between words were, that was made it a lot easier. Whereas this has all been compressed into one single string.
Yeah, and that's going to be a big clue later when we do a much harder challenge. We have been kind to you and given you that help of the spaces. But generally speaking, especially with binary, it wouldn't be separated because it'd be sent in a long string. There's actually another, we're not going to do it today, but there's another element to this, which is error checking, because quite often you'll send a big long strip of binary and there might be one thing that's out. And so there's a way of sending code in a sort of grid so that it's self-checking. So if you're interested, you can always have a look afterwards about error checking. But it looks like it's a bit like your on and off buttons that people are talking about. You look for whether there's something that doesn't look quite right in your grid, and that helps in checking mistakes.
Yeah. That's one of the things I find really interesting is that, if you sometimes, all it would take for a 0 to be a 1 or a 1 to be a 0, and suddenly you've completely changed the meaning of your message. Like, for example, it can be to make the difference between kill Bill and kill Jill. One letter is different, and you end up assassinating the wrong person. That's not going to work.
That wouldn't be ideal. No, it wouldn't.
So luckily, there are mathematical techniques that will allow you to be able to detect and correct errors in long strings of ones and zeros like this. But we can give you some resources to show you how that can work in practice, but we won't be looking at that today. You'll just have to be extra careful and make sure you don't make your own mistakes. Now
there is only a few seconds left, but if you haven't managed to do this, then do just take a photo, a screenshot, or on your phone and keep working on it later. Give everybody a couple minutes to carry on using the chat box. So the Menti has finished now. I can see 30 or so people.
Oh, that's good. Yeah.
Did it. I've got a few typos again, which I'm just being kind on typos today because I can see you got the right one. There's one completely. It just looks like maybe quickly tried to end something, or the hand slipped perhaps. But the rest of you have all got it right. And it's funny how the typos come up because lots of people have the same typos. 8 people have the same typo, so it's easily done.
Yeah, well done if you managed to get an answer there. This one is a tough one, but yes. All right. So what did we get for the answer with this? Hopefully, you managed to get the answer was ones and zeros, which is not surprising because we would expect it all to be ones and zeros. So well done if you got that. That one is probably one of the toughest ones that we've got here.
Definitely, and we're going to kind of go back to a fairly ancient type one now, but basically because it's going to lead us onto our final challenge, so there is a logic to it. Yeah, that's fine. You can move the slide on.
Yeah, okay, I'll move it on then. Right.
Okay. We are going to. I'm pretty much just going to give this to you without any explanation. So, this is what I would say is fairly intuitive. So, you've got it in front of you. I think that based on everything you've done so far, you'll be able to work it out. So I'm going to press start now. And if anybody has any questions or are not sure, then you can ask us. But I have faith in you.
That's very mean of you, Charlotte, not to give away how to do it. But then I guess that's the life of a cryptanalyst, isn't it? Nobody gives you the clues and tells you how to do it. You just get this garbled message and have to try and work it out.
Yeah, well, funnily enough, this has a clue on it. The next one isn't going to have a clue on it. But this is just well, hopefully you can all see what's going on here. Z is replaced with an A, and so on and so on. you might want to quickly write out your own key.
Yeah, I always find that this is the easiest thing, is just to write out the alphabet and then write out the alphabet underneath it backwards.
Yeah.
One thing I always wonder about this one is when you're encoding or decoding for this one, how do you know whether it's you're going from top to bottom or bottom to top? Well, I think that, you know, it's interesting for this particular cipher. It actually doesn't matter whether you're decoding or encoding, because they're both the same thing. So, for example, if you can see here that that the letter Y would be replaced by B, but then that would be the same here as well anyway. So B encrypts to Y and Y encrypts to or decrypts to B. It doesn't matter whether you're encrypting or decrypting for this one, which makes it a little bit special, that both encrypting and decrypting are both the same thing. Encoding and decoding are the same process in some sense in this one, which is quite interesting.
That is interesting. We're just going to have you type this to us in a message, if that's okay, because the Menti has
is it broken down?
It's gone for this slide, and it will take me too long to try and redo it. So yeah, if you just send us a message to host and put it panelists, then that would be great. I can see already Alessandro's got it.
Kathy's saying that this cipher is used for geocaching. I hadn't realized that. That's really interesting. I didn't realize they use that bash for this. If you're still struggling here and you're wondering what it is, well, I mean, maybe we can give a wee clue with the first letter. So this would be E, this is F, and this is G here. So G and T are encoded or decoded together. Yeah. So that first one would be a T.
And I like what you said about them being opposite. So actually, we don't even need this whole thing. Well, what's halfway through the alphabet? M and N, isn't it? So you could just do half the key and then just use it both ways. Don't need to write it all out. Scrabble
cipher. Yeah, that's a good point, Nigel.
Okay, Emma's got it as well.
Yes, I've seen a couple of good answers here.
Natalie's got it. Christabel. I think the first was Alexandra.
Well done.
And Louise, yes, I think answered that already. Aaron's got it. Louise has got it.
Brilliant. Excellent. Shall we give away the answer now, or are we gonna?
I think we'll just see if there's just a couple more coming in, and then we'll just
cool.
We will go back to Menti, because the next question will work on Menti. Just a bit of a change anyway going on to chat. We get to see your names as they're coming in. It's quite nice.
Which is always good.
All right, let's reveal.
Okay, let's see if we've got the answer. So the answer is this code was used to decode the Hebrew alphabet. Which is true, actually, of course, and it's actually where it gets its name from, isn't that right, Charlotte? Yes, exactly. So it originates from the letters in the Hebrew alphabet. So basically, as you said, the switch happening. So the Aleph and the Tav swapping over. Apologies if I pronounce this wrong. And hence the sort of name of the cipher Atbash, because it's those letters, the A and the T and the B and the sh kind of joining together. So yeah, we had a kind of this is how it would have originated with those letters, and it's a basic version, as Andrew said, of a monoalphabetic substitution cipher, a bit of a mouthful, which essentially means one thing is swapped for one thing, and the rest of the ciphers we're going to look at, well, the final cipher we're going to look at today, and another example we're going to look at are all those, and they're also known as simple substitution ciphers, which is easier to say. Simple meaning that there's just one swap for one. Now, we're not going to go into it today, but as I said, these are not really used anymore because they're too simple. What tends to happen is, there's different codes within a code. So certain letters will be coded with certain ciphers, and then other letters will be coded differently. So that makes it more complicated. What we're going to do today is just look at simple substitution. So one thing swapped for one thing, and that remains the same way throughout the whole message. So as Andrew said,
you can use that. Once you know what E is, you can swap it for all those E's in the whole message. Makes it a lot simpler. And as you can see, you can do this make it more complicated by adding sort of punctuation. You can add numbers. You can do different things to kind of make the alphabet more complicated. As we saw earlier with Pigpen, you can use symbols as well. Anything where there's one thing swapped for one thing is a simple substitution. If we go on to the next slide, another example, which again, we're not going to do today, but the reason we wanted to bring this up to you today is because at the end of this session, we're going to show you our app that we've been developing that we're quite excited about. And it includes a Caesar cipher in there. This is another example of a simple substitution. And this one is quite straightforward, like @bash, which just reverses the alphabet. This one just shifts the alphabet. So the alphabet stays in the same order. A is always followed by B and so on and so on, but it's shifted along. So you can imagine this wheel. Now, I always do this workshop in person with the students at Bletchley Park before the pandemic anyway. And we used to have paper Caesar wheels, which are really nice. You can use as nice paper clips to paper fasteners and get students to make their own, which is really nice. But you just spin it. So a shift of 3 would be moving the inner circle 3 spaces. So the A would move 1, 2, 3. So it was underneath the D. And Julius Caesar was known for using this, hence the name. And he supposedly used a shift of 3 all the time, which makes it not very secure, because if you always use the same shift, and everybody knows that, but that's apparently what happened. So using a shift of 3, this is an example here. You have to sort of visualize it because the wheel isn't spinning, but we can see that if A was D, then then you would end up with E being B and so on. And somebody's cracked it, Alessandro. This message actually gives us Bletchley Park. So you can do this in a grid. The wheel is nice as an interactivity, especially if you've got one that moves. But you can do it as a grid like we did with @bash. And all you're doing is you just move 3 spaces and then you start A, B, C, D. So it's kind of easy in that sense. And as I said, it's Julius Caesar's known for using it. I think there's a picture of him on the next slide. Yeah, again, for military messages generally. Again, as I said, it wasn't the most secure thing, because once you know that it's a shift of 3, it's very easy. But as Andrew said earlier with the skittily messages, it was kind of assumed that at least the person carrying the message, who was just somebody being ordered to send it, probably was literate, and therefore somebody the person carrying it wouldn't be able to read it, let alone decipher it. They wouldn't know that it wasn't just in normal Roman language anyway, if they were illiterate. So that's a basic version. But if we go on to the next slide, we can make it more complicated. So we talked about swapping A for Z and so on and so forth. We talked about shifting it by 3 for the Julius Caesar cipher, which is a shift cipher. But actually, you could just do it in a random way as well. You don't have to keep the order the same. So the question here, which is going to go on Menti, is how many different ways are there? If we're using the English alphabet A to Z, 26 letters, no punctuation, etc. How many different ways can we rearrange the alphabet? Okay, so I'm going to start the Menti now, and I just want you to have a go. I'm not so worried about speed for this one. It's more about who gets a close answer. So
yeah, think about all the different ways in which you could possibly jumble up the letters in the alphabet in some way, that all the 26 letters of the alphabet, how many do you think, how many different ways would there be? How many different keys could you possibly have for just jumbling them up in a random sort of order?
Exactly. And this is going to go on Menti, so I'm going to start it now, and you can type your answer in.
Great. We've got a couple of people have got some answers, some very precise answers. Be interesting to hear what their justification is for that.
Yeah, and we've got a couple of people. I think somebody has already had a go on Menti as well, so it's good. 10 people now, so quick answers going in there.
Brilliant.
Let's see. There's some common answers. There's common mistakes as well. So it should, the question should say, on Menti should say how many ways can the alphabet be rearranged. The previous question said that too, but that was an error. That's why I didn't, that's why I cancelled it for the previous. Okay, so Nigel's actually giving us a bit of an explanation, which is nice.
Yeah, that's brilliant.
So this is kind of a bonus question, but I think this is mathematically an interesting question. And it kind of shows us the importance of having tools for code breaking, because well, you'll see in a moment when we reveal the number, you know, that trying out every single option is not really a possibility.
Mm-hmm. Yeah, absolutely. No, I think this is an interesting thing that Nigel's saying here. He's saying that there are 26 choices for the first letter. So if we, you know, we've got 26 choices for how we encode A, but then once we've made that decision, we've only got 25 choices for what to encode B, and then 24 choices for C, 23 choices, and so on, like this, all the way down to 2 choices here, and then 1 choice here. All right. Are we ready to reveal the answer yet, Charlotte?
Yeah, I think it's going to stop Menti in about 3 seconds. Yeah, okay. Yes. So let's see. You reveal the answer. I'm going to see what answers we've got. So,
all right. So the answer, is what happens when you take all those numbers and multiply them together. 26 times 25 times 24 times 23 times 22, all the way down to 3 times 2 times 1, and you get this massive number here. It's sometimes written as 26 factorial. So that's 26 with an exclamation mark afterwards, as in maths is said as a factorial. And what we've got here is, let me clear these annotations off. That number, if you work it out, turns out to be over 400 septillion. So it's this number here. I'm not going to say it out in full, but it's over 400 septillion, which is a huge number.
Yeah, and there are a few common mistakes as well in the answers we got. So lots of you have said 26 factorial. Some of you have said 26 to the power of 26 or 26 times 26. Andrew started explaining why it's 26 factorial, but perhaps you could just reiterate that point that you started making.
Yeah, it's just so if we go back to this other slide, it's just a case of going of thinking of how many different ways we can assign letters. So it's for this first letter that we've got here, you've got 26 choices that you can have for that. So you've got 26 ways of encoding A, then 25 for B, because you've already made 1 choice, and then 24 for C, 23 for D. And then, so if you take all of those choices together, you multiply all of them together. So it's going to be 26 times 25 times 24, all the way down to 2 times 1 at the end. And that huge number that we have on the others, if you work that out, you get this massive number here as well. So yeah, quite mind-blowing. But the key here is that if you were to try to just crack a code that had been encoded as one of these 400 septillion different ones, and you could check them at a fairly fast rate of 1 of these per second, then it would still take you roughly 1 billion times the lifetime of the universe to check all of them and find the right one. So yeah, a long time. Now, so you can't really use a brute force approach here. You can't just check all of the different combinations. This is the point we're trying to get across here. You have to be a bit more clever about it. And that's what people at Bletchley Park had to do.
Definitely.
So, yeah. Oh, and by the way, yes, this number here is said as 400 septillion, which can also be written in these other sorts of ways, 4 times 10 to the 26 as well. And here, if you're not sure why it's called septillion, Well, it's just how we name very large numbers. We start with millions and then add 3 zeros and we get billions, then add another 3 zeros, you get trillions, quadrillions, quintillions, sextillions, and then septillions is next after that.
I think at this point I might just share the leaderboard, if that is okay.
Yeah, go for it, yes.
It's just a little bit of fun, so don't worry too much, but let's see. Okay, so hopefully you can see that. We've got, at the moment, we've got Cameron, who's taking the lead as the fastest, Christabel and Jane following closely behind.
So close at the top there. Well done.
Very close. Yeah, and again, it's just about speed. So well done to everybody. Everybody who made here is the top 10, I think. So you've all been very fast code breakers. All right, I'll stop sharing and we'll go on to the final challenge. Okay, so a few of you have said, well, a few things have cropped up today about code breaking and different ways that you might use clues and different things that you might use. And so far, we've been very kind to you, really. We've given you the key every time. We've given you a clue, at least, as to how to solve it. And we've told you how it was encrypted, the type of cipher that was used to sort of hide the message. But, you know, in reality, we're not going to do that. If we want to keep the secret message, I'm sending it to Andrew. I don't want you to see it. Then I'm not going to tell you what the key is. So I'd be really interested, and I know somebody's already mentioned this in the chat, so you know, I know somebody's heard of this sort of approach, but what do you think you might do if you got a message? And again, there is a bit of a clue because the spaces are there, which is kind of us. But other than that, what kind of things could you use to help you to crack this? There's no key. So what do we do?
Yeah, this is all you're getting given. If
you're getting given, yeah.
Yeah, how would you even go about it?
And we know that you can't try every single key because it will take you forever, literally forever. Somebody said, Amiko said frequency analysis. Can you tell us a bit more about that? I know that Nigel mentioned that earlier as well.
There's a good point. Chris is saying that the most common letter is likely to be E. Now, there's a good one. Why is that? Why do you think the most common letter is likely to be E? And Nigel's saying it's like Scrabble, scrambling. Also, Kathy's saying maybe the C-A-N, or I think she means C-V-H. I think she's got correct. Has just changed her. Was that your dog barking in the background, Charlotte?
Sorry, I just thought I was on mute. Yeah, there's somebody delivering a parcel, I think. So bear with me.
No problem. Yeah, CVS might be the, because it's a really common word. Some brilliant ideas here. Yes. E is the most commonly used letter in the English language. So that's brilliant. So that's possibly the one that appears the most often is probably going to be an E. And CVS, which appears quite a few times, we could make an educated guess. There's CVH, there's CVH again. There it is again. I'm sure it appears more other places as well, but it could be the word the, possibly, because Definitely. That's a really common word, 3-letter word.
I think we're going to use all of these clues now. I'm going to share my screen with you. Please excuse me.
Don't worry about it.
I'm going to share my screen with you, and we're going to use a tool on Simon Singh's website. So,
let me stop sharing, and I'll let you do it. There you go.
Okie doke. Okay. What I might do is just mute myself shortly because of the dog. But what we're going to do is use all of those tools that you've just been talking about, and as we work things out, we're going to start putting it into this key. Basically, we're going to create our own key. So we're going to take the alphabet letters A to Z, which are in the cipher text, and we're going to guess what they actually are in real life in the plain text. Okay, and we're going to use clues like you said. So I think I might start with your guess of the. We could type in
C might be T,
right?
V
we could try that,
and H might be E.
We could try that. Another thing that we can use, which somebody mentioned, is frequency of letters, and we've kind of skipped that as our first thing, but we can do that now. If I click onto this chart here, it actually, can you see that?
No, it doesn't come up for us, unfortunately.
Okay, that's fine. Well, what it tells me, I'll tell you what it says. It says that H N has the most frequency and H is the second. So H and N are both like in the cipher text very common. So we would expect either H or N to be E, probably. Now your guess is that H is E. So I think that sort of makes sense. If that works, great. If it doesn't, we can try E as for N. But this looks like it works because if we have a look at the message, you can see at the top here that there's some there's in there and other things we need to check that make sense. So where other places where H and E's are coming up, do they work? We've got a T and an H here together. So that works.
Christabel is suggesting perhaps X is actually an O. What do you think about that?
And where does that come from, Christabel?
I think
it might come from this.
Absolutely, yeah. And Aaron is suggesting that YXP could be the word and. YXP could be the word and.
So that's fine, but that means we have to change X from O to N. So
but then you
try it.
You can try it, but I think you then get TN. Nah, I'm not sure that one's going to work. When we go back to X being O, I think that makes sense because then we had that word to TO.
Yeah. And this is what happens when you do this. You do have to keep checking and amending.
Any other suggestions of what we could do here? What could that YXP be if there's an O in the middle of it? I think X is a vowel based on one of the last words with a double Q. Yeah, possibly, yeah. It could be a T though as well, couldn't it? Because you get double T's quite often occur in, yeah. Okay, YXP could be for, we're suggesting. So YXP could be for, so.
Well, we've already got O as X, so that works.
Okay, and then P could be an R. Now, what does that give us? Oh, that gives us the word for. This is looking good. This all looks like it could be English. K looking like an A or an I. K looking like an A or an I. Should we try that? Yeah, that makes more sense than an A because otherwise you would have AE there, I think. What else have we got? Looks like the word school is in there, someone said. Oh, is that because of that?
Because of this word?
Yeah, possibly.
So that word is this word, right? So that would make FL. Yeah. That would make ES. That would make ZC.
Now, does
that looks good, and you have to check that it makes everything else look okay.
Ooh, now this is looking very, very good, actually.
Something is the something. Yeah, this looks good. So what could this be? We've already got S, so it's not going to be is, but it's not that many words that start with I and 2 letters. So I think we can probably guess that one.
Christabel's saying that that we might have N equals N, but I don't think that's necessarily a problem.
It could be N equals N because it could be in, but it could also, yeah, because it can't be it actually, because we've already got T.
Yeah.
It could be N equals N. It's interesting because earlier when we were talking about the alphabet, reordering it, Bob had said, surely there's one less because the alphabet already in order isn't a cipher. It's how it already was. But actually, maybe you wouldn't have every single letter in the same place, but sometimes individual letters can end up in the same place as they started.
Yeah, definitely. I think that word is going to be thing then, is we're getting a suggestion that this word is thing, so that should be a G. The B should be a G.
Great. Well, we're getting there very quickly as a team.
Definitely. Natalie's suggesting that the first word is friendship.
Nice. Okay, let's see. So that makes L and F. Oh, have we already got an F somewhere?
I don't think so.
We do. We already have an F. So it doesn't mean you're wrong. It just means that this F is not. If that is friendship, then that's not an F and that's not an R.
Ooh.
Which is not wrong necessarily, because actually this word is a bit funny. This could only be art, right? So maybe that 4 isn't actually right. But let's try let's try. Was it Natalie who said that?
Yes.
Let's try what Natalie's saying and move the F and the R.
Yeah.
See what
And then, excellent. And then that would mean that what's a D then? That would be, is that M is D? M is D. And then P, what's the last one? G is P. Friendship is that, oh, this looks good. So that word, someone said in the chat, hardest. They thought that word was hardest. So that would make R is A. Yes.
Well, this is looking good.
Someone also suggested that that word was world, where you've got oral there. So that must be a W. So W is W.
W is W. That's okay.
Is the hardest.
Friendship is the hardest thing in the world too.
Explain, someone's suggesting. So that's Kathy suggesting explain. So yeah.
It's not.
I think that's going to be something. Yeah, we've got someone suggest something you learn in school.
So U. So we need to put Y and an O here. So we've got a few things matching up. Y and Y again. It happens. It's random and it happens. And actually, I think that I might be wrong about this, but I think that one of the clues that they used at Bletchley Park was that they, the decoders, the encryptors, made sure that the letters never actually were the same. And actually, that is actually not a good idea, because then you're ruling out loads of options. Because there's many of those different keys will have had some of the letters the same, and they've ruled all of those keys out. They've reduced the codes to crack. Right, what do you think this one is?
I think we've got someone has suggested but. So that must be O, must be a B. Yeah.
I think we're nearly there. We've got a couple of letters left. This one.
That must be a V. Surely I is V. Someone's suggesting I must represent V. Yeah, that's
okay,
it.
I think we're it. So friendship is the hardest thing in the world to explain. It's not something you learn in school, but if you haven't learned the meaning of friendship, you really haven't learned anything. Muhammad Ali quote. Okay, well that's kind of pretty good. Pretty good timing there. We've just got a few minutes to just show you a few other things that you might like to do, carrying on your experiences with code breaking, really. So I'll stop sharing. That was on Simon Singh's Black Chamber. So if you're interested in carrying on, you can go on to Simon Singh's website. I'm going to add some links up shortly. So yeah, first of all, thank you for taking part. And then we're just going to share with you a few links. So I shall just copy and paste these in the chat box for you. And perhaps Andrew can just say a couple of things about what's there while I get those links ready.
One of the things that's particularly interesting, what Charlotte was using there, that was Black Chamber from Simon Singh. And someone already mentioned in the chat box that Simon Singh wrote an excellent book called Code Book about code breaking, about the history of it as well. So that's also a really good one to go to as well. So
I'll put those links in the chat box for you. So please do copy them over. Brilliant.
There's also OpenLearn as well. If you want to learn more from the Open University, from us, we have loads of stuff on OpenLearn for courses. We also have some puzzle apps, one of which is very, very new, which we're very excited about as well. So maybe Charlotte will say a little bit first of all about Perplex. This is one of our popular puzzles, and then this is going to be our newest exciting thing is that we have a new app called Codebreak, which is being released very, very shortly. And I think that we're going to get a very quick sneak peek of it just now if Charlotte has the ability to do so. So this is something that Charlotte and I and our colleague Katie Chico have been developing over the past couple of months or something. And you'll recognize some of the puzzles that you've seen here today. So we've got the pig pen. So there'll be a timed challenge for you to be able to do pig pen. But now that you know how to do pig pen, you'll have a distinct advantage over everyone else who's not getting told how to do it. We also have the Caesar Cipher. We talked, or Charlotte talked about the Caesar Cipher as well. We've got where you've got a wheel that you can turn and shift in the way that Charlotte described before. And also a chance to try your own frequency analysis as well. So, Charlotte, do you want to? Are you ready to share it?
Yeah, hopefully you can see that now.
Yeah.
Yeah, so I've actually gone into the program. So you'll get a landing page which looks like this. There is some music. I've muted it for a moment because it's you might not be able to hear it from my computer anyway, but it's a sort of mysterious music. And you can see this lovely graphic here. We made this in collaboration with Maths Week Scotland, and so it's a really exciting new game. It's actually not on the website yet, but it's going to be on Open Learn within the month, hopefully, or within October, early November. And what you'll find is a few bits of information that you can go off and explore on our website and on Bletchley Park. But then the exciting part is that you'll also be able to play the game. So I've had a go at this myself and tried to get 3 stars. But you'll find one version of Pigpen, as Andrew said, where you have a message to decrypt. And after a certain amount of time, this is your timer going down. After it gets down to sort of 2 bars, which is 2 stars, then it will give you a hint. You won't need it because you're all experts now. But you type your answer in here and you can check it. So I can type in an answer and it will tell me, no, not quite right, have another go. And then you'll see what happens is when you play this game, these are locked. I've unlocked them because I've been playing on it. But you have to unlock the previous game in order to open the next one. Again, I'm just running through this really quickly because of time, but hopefully you'll have a play on it once it's live. You're going to have a little bit of information about it, a little bit about the history, and then you get to have a go. And this is quite exciting because it's an interactive Caesar wheel. The wheel spins around so you can see the whole alphabet, and then you can do your shift. So again, I might click shift of 3 as a guess. I'm generally going to be using tools like we just did in frequency analysis as my kind of guesses. So I might guess that this might be an A if it's a single letter. I might guess that this might be a 2 TO or something like that, and use that to guess. And once I've got my key, I can crack the rest of the message. So it's all very exciting. And the final one, which is just like what we just did, is the frequency analysis, which is for cracking simple substitution ciphers. So again, there's a little bit of information for you and gives you some information about frequency analysis. And then you've got this nice interactive where you can type in your guesses. And what will happen is the text at the top will change to show you, obviously I've put in random letters, but it will change to blue to show you what the message is. And you can see if it makes sense. I would clearly say here, this isn't a word, so I've obviously made a mistake. Go back and change it. Yeah, so it's really exciting. And we've got all of your email addresses from Eventbrite, so we shall send the link out as soon as it's ready. Yeah, thank you very much for attending. We hope you enjoyed it.
That's it. Well, yeah, unfortunately, that means it's the time. It's time for us to say goodbye. But I really hope that you've enjoyed yourselves. Thank you so much for coming, and we very much look forward to speaking to you again soon. If you've got any questions about anything, you should be able to contact us through Eventbrite. We'd really love to hear from you. And yeah, hope you enjoy Codebreak, and I hope you enjoyed today's session. Thank you so much, everyone.
Thank you so much.